Number one, black hole. Space is silent. There's no air, no atmosphere, no medium for sound to travel through. If you screamed in space, no one would hear you. So when NASA released what they called the sound of a black hole, it confused and disturbed millions of people because it did not sound silent. It sounded like a deep, haunting cosmic moan, something ancient, something alive. But here's the truth. This sound comes from the Perseus galaxy cluster, located about 250 million light years away from Earth. At the center of this massive cluster sits a supermassive black hole. It is millions, possibly billions, of times more massive than our Sun. NASA's Chandra X-ray Observatory studied this region and discovered something extraordinary. The black hole was not just sitting quietly in space. It was sending out pressure waves through extremely hot gas that surrounds it. Imagine dropping a stone into water. Ripples spread outward in circles. Now imagine something the size of a solar system, creating ripples in a sea of superheated cosmic gas. Those ripples are real. They carry energy. They carry vibration. But space has no air. So how can we hear it? The answer is something called sonification. NASA did not record sound the way a microphone records your voice. Instead, scientists detected pressure waves in X-ray data. Those waves were translated into sound frequencies that humans can hear. Originally, the vibrations from this black hole were 57 octaves below middle C. That is far below the range of human hearing. In fact, it is one of the lowest frequencies ever detected from an astronomical object. So NASA raised the pitch. When shifted into our hearing range, those ancient pressure waves became that deep, unsettling tone. What you're hearing is not fake. It is not edited for horror. It is real scientific data transformed into sound. And the reason it feels so disturbing is psychological. Our brains associate very low frequencies with danger. Thunder, earthquakes, massive predators, low sounds signal something big, something powerful, something beyond our control. This black hole has been producing those pressure waves for millions of years, long before humans existed, long before Earth looked the way it does today. Right now, as you're listening to this, that black hole is still vibrating the surrounding galaxy cluster, slowly, endlessly. Space may be silent, but it is not quiet. And sometimes, when we translate the universe into something we can hear, we discover that it has been humming all along. Number two, Juno, Jupiter's radio emissions. If you could convert radio waves into something your ears could understand, Jupiter would not sound peaceful. It would sound terrifying. When NASA's Juno spacecraft approached Jupiter, it did not just take pictures. It carried instruments designed to detect radio and plasma waves coming from the planet's massive magnetic field. What it discovered was intense. Jupiter does not just spin quietly in space. It generates powerful radio emissions. These emissions are created by charged particles trapped inside its enormous magnetic field, the largest planetary magnetic field in our entire solar system. Jupiter's magnetic field is so strong that it stretches millions of kilometers into space. When particles from the sun collide with this magnetic shield, they accelerate along magnetic field lines toward Jupiter's poles. This creates enormous auroras, far more powerful than the northern lights on Earth. And during this process, radio waves are produced. Radio waves are not sound. You cannot hear them in space. But Juno's waves instrument detected these signals and converted them into frequencies humans can hear. The result sounds almost artificial. Metallic shrieks, rising whistles, electronic howls, rapid crackling pulses. Some parts resemble a science fiction movie. Others sound like a distant alarm echoing through darkness. But this is not special effects. It is physics. The strange tones come from electrons spiraling along magnetic field lines at nearly the speed of light. As they move, they emit what is called cyclotron radiation. When translated into audio, those electromagnetic waves become the eerie sounds we hear. The closer Juno flew to Jupiter, the more intense the signals became. At times, the audio spikes sharply, like something screaming. And in a way, it is. It is the sound of charged particles colliding with the most powerful planetary magnet in the solar system. Jupiter is often called the protector of Earth because its gravity absorbs comets and asteroids that might otherwise hit us. But listening to its radio emissions reminds us of something else. Jupiter is not gentle. It is a giant storm world with lightning storms, larger than continents, winds faster than any hurricane on Earth, and a magnetic environment so extreme it can destroy spacecraft electronics. Those strange sounds are not cries. They are energy. They are magnetism. They are radiation made audible. Right now, as Jupiter rotates once every 10 hours, those radio emissions are still being produced. Invisible, constant, violent. Space may be silent, but if we translate its hidden signals, Jupiter does not whisper. It screams with electricity. Number 3. Sound of Saturn's rings. When NASA's Cassini spacecraft entered Saturn's orbit, it detected something strange. And when scientists converted that data into sound, Saturn did not feel quiet. It felt haunted. Cassini was launched in 1997 and spent over 13 years studying Saturn, its moons, and its famous rings. During its mission, it carried instruments designed to measure plasma waves and radio emissions, invisible energy moving through space. Saturn's rings may look calm and beautiful from a distance, thin bands of ice and rock glowing in sunlight. But up close, the environment is anything but peaceful. The rings are made of billions of particles, some as small as dust grains, others as large as mountains. They constantly collide, bounce, and interact within Saturn's powerful magnetic field. As charged particles from the sun move through this magnetic field, they create electromagnetic waves. Cassini's instruments detected these waves and recorded the fluctuations in energy, but electromagnetic waves are not sound. So how do we hear them? Scientists used a process called sonification. They converted the radio and plasma wave data into audio frequencies that humans can hear. Sharp bursts, sudden pops, whispers of energy moving through darkness. It almost feels like you are drifting through a storm made of electricity. In 2017, during Cassini's grand finale, the spacecraft performed daring dives between Saturn and its rings. As it passed through this region, the instruments picked up rapid bursts of particles striking the spacecraft. In the audio, those impacts sound like tiny sparks hitting metal. Each crackle represents real material from the rings. Each burst is a piece of Saturn touching the spacecraft. And then, after years of orbiting the giant planet, Cassini made its final descent. To protect Saturn's moons from contamination, the spacecraft was directed into Saturn's atmosphere, where it burned up and was destroyed. Its final signals faded as it entered the planet. But the data it sent back remains. When you listen to Saturn's rings, you're not hearing wind or voices. You're hearing radiation, magnetism, charged particles colliding in one of the most extreme environments in our solar system. From far away, Saturn looks peaceful, elegant, silent. But hidden within its glowing rings is a constant storm of energy. Space may be silent, but when we translate the universe into something we can hear, even Saturn sounds alive. Number 4. Voyager 1, the sound of interstellar space. When scientists released audio from beyond our solar system, it felt impossible because it sounded like something was out there. In 1977, NASA launched Voyager 1 on a mission to explore the outer planets. It flew past Jupiter, it flew past Saturn, and then it kept going, farther than any spacecraft in human history. In 2012, Voyager 1 crossed the boundary of the heliosphere. the protective bubble created by the sun's magnetic field. It entered interstellar space. For the first time, a human-made object was traveling between the stars. But Voyager 1 does not carry a microphone. It cannot record sound the way we record voices on Earth. Instead, it carries a plasma wave instrument. Plasma is a state of matter made of charged particles. It exists throughout space. Even in the emptiness between stars, there are extremely thin particles drifting through darkness. As Voyager moves through interstellar space, it detects vibrations in this plasma. These are not sound waves. They are oscillations in electrically charged particles. Scientists convert these plasma waves into audio frequencies we can hear. The result is unsettling. High-pitched whistles, rising tones, electronic-like signals that almost resemble distant alarms. When Voyager first entered interstellar space, the plasma density changed dramatically. That change produced a distinct tone, a higher pitch than what was detected inside our solar system. It was the sound of crossing a boundary, the sound of leaving home. What makes it eerie is not just the tone itself, it is where it comes from. Voyager 1 is now more than 20 billion kilometers away from Earth. Its signals take over 20 hours to reach us. It is drifting through a region where sunlight is faint, and stars are no longer just distant points. They are the neighborhood. The sound you hear is not a voice. It is not an alien transmission. It is the vibration of interstellar plasma, matter so thin that it would be considered a vacuum by any standard on Earth. Yet even in that near-perfect emptiness, there is still motion, still energy, still vibration. Right now, Voyager 1 continues its journey. Its power is slowly fading. One day, it will go silent forever, but it will keep traveling for thousands, maybe millions of years, carrying a golden record with sounds of Earth. And behind it, recorded in data, is the strange whisper of interstellar space. Space is silent, but even between the stars, it is never truly still.